All right, guys, so 8.1, we're talking about the average value of a function, which is very different than the average rate of change. But there's a good chance both of those questions are going to get asked to you on the same page of the AP test. So average value, we're going to start there, then we'll get on to accumulation functions. So this is just kind of an example of how this formula came up. So you've got a little diagram here. You've got y and the x-axis. You've got f of x, which is this function here. And what it asks me to do is to draw a horizontal segment from x equals a to x equals b that would represent the average height. So when I look at this function when x is equal to a right here, my height's up here. When x is equal to b, my height's down here. So the average height is maybe somewhere in the middle. So it wants me to draw a line that represents the average height. So that height is kind of my average value, right, of whatever this f of x function is. In order to figure out what, like if I write that as an area function. So from A to B, I've got this rectangle being created that goes up to whatever that imaginary height I came up with is. So if I write that area formula, area equals, I know it's written right here, but we've got width times height. The height is what I'm looking for. The height is that average value, right? What I do know is I know the area, maybe. Well, we'll find the area another way, but the width of that rectangle, it goes from A to B, so the width is going to be B minus A. So my function for the area of that rectangle would be B minus A multiplied by whatever that height is. Okay, so they use that idea to come up with the equation of an average value of a function. And the average value equation, well, I guess the next step to come up with it is they said that the integral from a to b of f of x dx is equal to b minus a multiplied by the height. So remember the integral from a to b, that function, the integral is going to help me find the area under the curve like this black part that I'm highlighting. But instead of finding the area under the curve, if you took the average height and found the area of that rectangle, they should equal each other, right? The area under this curve should be equal to the area of that rectangle. So that's why those areas are equal to each other. Then it says solve for the average height. So I divide by b minus a. And that's what gives us our average value function. You don't need to remember how it was created. You need to absolutely have memorized this average value function because it is going to come up and it'll probably be on the free response. They love this as a free response question. And it doesn't matter which of these two forms. Notice there's a big or in between. Both of these forms work, okay? So let's use this average value formula. It's really basic, okay? It's a basic formula. You plug in the pieces to figure out what that average value is or what the height of that rectangle would be. So example 4 says, find the average value of f of x equals x cubed minus x on the interval 0 to 2 without using a calculator. So I'm going to start at 0, and my function is going all the way until I hit 2 right here. And it wants me to find the average value of the function. So rather than try to figure out the height from the graph, I use the formula. The average of f, the average value of f is equal to, I'm going to do the integral from 0 to 2 of the function, so x cubed minus x. I'm plugging in data into that equation right there. The integral from 0 to 2 of x cubed minus x dx. And then I have to divide that by b minus a. So that's 2 minus 0. And then I start solving. So the bottom's going to be really easy because the bottom's just going to become 2. The top, I have to integrate x cubed minus x. So I've got 1/4 x to the 4th minus 1/2 x squared. And I'm going from 0 to 2. So that has to be evaluated from 0 to 2. So let's keep going. Plug in the 2 first. So I'm going to focus on the top here first. I'm going to plug in the 2. So I get 1/4 times x to the 4th, which is 16, minus 1/2 times x, or times 2 squared, which is 4. And then I have to minus plugging in 0. So I get 1/4 times 0 minus 1/2 times 0. And all of that gets divided by 2. So what do I end up with? 1/4 times 16 is 4. Minus 1/2 times 4 is 2. The rest of that becomes 0 divided by 2. So I end up with 2 divided by 2. So the average value of f of x from x cubed minus x is equal to 1. So that means my height would have been right here. That would have been the height of my function, okay? All right, going on. Example 5, it wants me to use a calculator to find the value of c in the interval from 0 to 2 where f of c equals the average value we found in example 4. So what it wants me to do here is it wants to know on the graph, now that I've like colored over all of the graph, it wants to know what x value does my function equal that 1. So it wants to know this point right there. It wants to know what is the x value that gives me a y value of 1. So what is, and it calls it c, what x value c gives me an output of 1. So the way I usually write that, it wants f of c to equal 1. So it wants x cubed minus x to equal 1. So we're going to graph that. So it says to use a calculator because trying to solve that right there would be an absolute mess. So you go to your calculator, and I'm going to go to y equals, and I'm going to type in x, here we go, x cubed, x to the 3rd power, minus x. And I'm going to go to the graph. Now on the graph, I want to know where it is equal to 1. So there's 2 ways to do it. The way I usually do it is I just make another graph that equals 1, and I find where those cross. I just look for that point I look for this point where they cross each other. I use that calculate intersection button. So you go to calculate, intersection, and all you have to do is click on the left, and then you go to the right. We've used this before. So it tells me that it intersects when x equals 1.324. So I would say the c value is 1.324 is where it's going to equal 1. The other way that you can do that, there's other ways to find that if you don't want to make another equation. A lot of you like to use the table. The problem is trying to plug in an x value that gets you a nice output of 1 is difficult to do. So others I've seen just trace, and they just like try to estimate what it's going to be. They just keep moving back and forth until their y gets close to 1, which again, I don't think is a very good method of doing that. So I prefer y equals 1. That's how we've done it in the past, and that's what I would do if I was you. Okay, so that is average value. There's only these 2 examples on the note part of this, because in the homework, it's just plugging stuff into a formula. So numbers 1, 2, 3, 4, and 5 are different finding average value problems, practicing what we just did. Some of them it wants you to use the calculator, sometimes it doesn't, because the way it'll present these problems, sometimes it gives you the function, right? Sometimes it gives you this exact equation. sometimes all it gives you is the graph. Sometimes it'll give you something like, it'll give you the shape of the graph, and it'll want you to find the average value, and you have to use, to do the integral part, instead of actually integrating a function, you find the area under the curve, and you use that to find the integral, okay? Sometimes it gives you a really ugly function that you can't integrate in your head or on paper, so it wants you to use the calculator for that part. So it presents different ways of doing these problems, but all of them are the same. You find the integral, whatever method, whether you integrate, calculate, or graph, you find this value and you divide it by b minus a, and you're good, okay? So we'll practice a few of those in class together. For now, you're not in class together, so practice those on your own. All right, accumulation of rate functions. The second part of this homework assignment is it wants you to use some of this information. It wants you to use what you know about rates and integrating and area under curves to, they call them accumulation functions because you are accumulating the area under the curve is basically why they're called what they're called. So here's an example, and you'll notice that these are accumulation of rate functions. So all of these functions, your y value is a rate. So in this case, in this problem, it's the rate of rainfall. So how fast rain is falling, and then your x value is different times in the night after midnight, it says, okay? So number 6 says to write a complete sentence to explain what point A on the graph represents, include numbers and units in your answer. So point A is right here. So point A, the way I write this sentence, and this is a pretty common question on the test as well, it wants me to describe that point. So point A represents, so maybe I should say A. A represents do we want to use yeah, we better use the number because it actually gives us what that value represents, right? It actually gives us the value of A. It's not, we know that it's 1, the y value. So A represents the rate that rainfall is happening, is kind of the general description, right? But the specific description would be that at 3 a.m., because that's my x value, at 3 a.m., the rain is falling at a rate of 1 inch per hour. So at 3 a.m., the rain is falling at a rate of 1 inch per hour. If it didn't give you the values, you would use the first description. When it does give you the actual measurements, then you would use the second description. You would use those measurements in your description. Number 7, what is the slope of the graph between B and C? So number 7 wants to know the slope of my graph. So not the value, it wants to know the actual slope from B to C. So I'm going, remember slope, rise over run. Again, I'm not going to assume that this is just common sense. So we are going down 1 and we are going over, right? Because we're going from 4 to 5. So we're going from 4 to 5 and we're going down 1. So my slope, M, is going to equal -1. Doesn't want the units on this one. Nope, it just said 6, 8. So we're good to say just M equals -1. Write a complete, oh, here's the explanation. Write a complete sentence to explain the meaning of your answer in example 7. So you would say from 4 a.m. to 5 a.m., the rate of rainfall decreases at a rate of -1 inches per hour, because we're taking the rate of a rate. Number 9, find the integral from 3 to 5 of r of t. It's been a long day, guys. Integral from 3 to 5 of this function. So it wants me to find the area under the curve from 3 to 5. So I'm going to do that geometrically. I'm going to use this area right here because I don't know the actual function, and I'm going to use that rectangle and that triangle. That rectangle has an area of 1. That triangle has an area of a half. So the integral from 3 to 5 of r of t dt is equal to 1 plus a half. So that's going to be 3/2 or 1.5, whichever one you prefer. 10, write a complete sentence to explain the meaning of your answer in example 9. So the area under the curve represents the amount of rain falling. So the area under the curve represents how much rain has fallen in that time. So from 3 a.m. to 5 a.m., 1.5 inches of water has fallen. So that area represents the amount of water that has accumulated from 3 to 5. Again, that's why it's called an accumulation function. Number 11, approximate the value of the integral from 0 to 6 using geometrical regions. Okay, so now it wants me to go all the way from 0 all the way up to 6. And I've already found from 3 to 5. We already know that's 1.5. So now I've got to, well, from 5 to 6, that geometric area is 0, so I don't even have to worry about that one. From 0 to 3, I've got this funky line, and you can do this in a lot of different ways. You could make a bunch of different triangles if you wanted, like this. You could make rectangles. You get to decide how you make up that shape, whatever's the best way to do it. I'm just going to make it simple. I'm just going to connect this point to this point and make one big triangle, and I'm going to find the area of this big triangle right here. And now I'm just estimating, right? So it's okay. It's not a perfect estimate. It's not an awful one, but it's not perfect either. So the area of that, let's see, it's 3 wide, and it's 1 tall, so it's 1/2 of 3, which is another 1.5. So my area is 3, we better write we did 3 times a half plus another 1.5 plus 0. So a half plus a half, or 1.5 plus 1.5 equals 3. Write a complete sentence to explain the meaning. So what does that mean? Well, it's really similar to 10. What that means is from midnight, because 0 represented midnight, to 6 a.m., 3 inches of water has fallen. And if you wanted to say a total of, anything like that is going to be good enough, okay? That's his only accumulation example too. So we'll probably do a couple in class together as well. Maybe, start them, let you finish them at home. So those of you that are going through this at home, which is all of you because I'm not there today, when you come to class, we can do some of those other examples if you want.